Time dilation and space contraction, mechanisms leading to time dilation and space contraction in relativity and their effect on the measurement of time and distance in the universe. Time dilation and space contraction are fundamental concepts in the theory of relativity that describe how time and space are affected by motion and gravity. These effects have a significant impact on our measurements of time and distance in the universe. According to the theory of relativity, as an object approaches the speed of light, time appears to slow down for that object relative to a stationary observer. This effect is known as time dilation and is caused by the fact that time and space are not absolute but are dependent on the relative motion of the observer and the observed object. Similarly, the theory of relativity also predicts that objects that are moving at high speeds will appear to be shorter in the direction of motion than they would if they were at rest. This effect is known as space contraction or length contraction and is also caused by the relative motion between the observer and the observed object. The effects of time dilation and space contraction have been observed in numerous experiments and have important implications for our understanding of the universe. For example, the time dilation effect has been observed in experiments involving subatomic particles, where their lifetimes are found to be longer when they are moving at high speeds. The effects of time dilation and space contraction also have important implications for our measurements of distances in the universe. Because the speed of light is the maximum speed at which information can be transmitted, the time it takes for light to travel from a distant object to Earth can be used to calculate the distance to that object. However, because of time dilation and space contraction, the time and distance measurements made by a moving observer will be different from those made by a stationary observer. In addition to their impact on our measurements of time and distance, the effects of time dilation and space contraction also have important implications for our understanding of the behavior of matter and energy in the universe. For example, the theory of relativity predicts that the energy of an object is related to its mass through the famous equation E equals mc squared. In conclusion, the effects of time dilation and space contraction are fundamental concepts in the theory of relativity that describe how time and space are affected by motion and gravity. These effects have important implications for our measurements of time and distance in the universe and have contributed to our understanding of the behavior of matter and energy in the cosmos. Furthermore, the effects of time dilation and space contraction also have important practical applications in modern technology. The Global Positioning System, GPS, for example, relies on the principles of relativity to accurately determine the position of objects on Earth. The GPS system uses a network of satellites in orbit around Earth to transmit signals to GPS receivers on the ground. Because the satellites are moving at high speeds relative to the Earth's surface, their clocks are affected by time dilation and run slightly slower than clocks on the ground. Without taking this effect into account, the GPS system would be inaccurate by several kilometers. To account for the effects of time dilation, the GPS system uses highly precise atomic clocks on the satellites and on the ground to accurately measure the difference in time between the two locations. By taking this into account, the GPS system can accurately determine the position of objects on Earth to within a few meters. In addition to the GPS system, the principles of relativity also play a role in the design of particle accelerators and other high-energy physics experiments. The behavior of subatomic particles at high speeds and energies is governed by the equations of relativity. and the effects of time dilation and space contraction must be taken into account in the design of these experiments. In conclusion, the effects of time dilation and space contraction are not only fundamental concepts in the theory of relativity but also have important practical applications in modern technology.